Ink manufacturing. Historical versus modern methods. The processes used to make ink have evolved dramatically from ancient times to today, reflecting changes in scale, chemistry, and technology. Historical ink making. In ancient and medieval times, inks were made in relatively small batches from locally available ingredients. Recipes were often closely guarded secrets passed down through guilds or families. A historical ink maker, say a medieval scribe or a Chinese ink artisan, would start with raw materials like soot from lamps or pine resin, natural dyes, plants, mollusks, minerals, tannin-rich galls, etc. Preparation was manual. Grinding and mixing. Dry materials, pigments, gums, were ground by hand with mortar and pestle. For example, to make India ink, lampblack soot was laboriously ground with a solution of hide glue, sometimes perfumed or mixed with a bit of camphor, then poured into molds to harden into ink sticks. Cooking. Some recipes require gentle heating. Early iron gall inks often involve simmering the gall extract in iron salt to encourage the chemical reaction that produces the dark pigment. In Europe, ink makers boiled bark or galls to extract tannins. In the 19th century, some color inks were made by boiling dye materials to concentrate them. Fermentation. Interestingly, certain ink recipes, especially iron gall ones, were allowed to ferment for days to weeks. The organic matter breaking down could affect the color and properties. Trial and error. Without precise instruments, historical makers judged an ink by appearance and behavior. Does it write well? Too thin? Too pale? Consistency between batches was a challenge. The scale was also small. Monks might mix a few ounces of iron gall ink for their scriptorium. An artist might prepare fresh ink each week. Pigments like indigo or ultramarine were precious, so ink ingredients were carefully portioned. Additives were natural. Honey or gum for thickness, vinegar or wine for acidity. Salts, like rock salt, or alum for effects on color, etc. Once made, inks were stored in ceramic or glass inkwells and had limited shelf life. Mold could grow, or they could dry out. Stability was an issue. Many old formula books mention adding a clove or a drop of carbolic acid to prevent mold, especially in iron gall inks that had organics. Modern ink manufacturing. Today's inks, especially for printing, are made in large factories with a high degree of precision and quality control. Key aspects of modern production include bulk mixing. Ingredients, solvents, resins, pigments, additives are measured by weight and combined in reactors or mixing tanks. For example, in making a printing ink, a varnish, oil yao resin mixture, might be cooked in a kettle. Then pigments are added and mixed in. Grinding and milling. Achieving fine pigment dispersion is critical. Modern ink factories use machines like ball mills, bead mills, or 3-roll mills to grind pigment particles and thoroughly mix them with the vehicle. The goal is to break pigment agglomerates and wet every particle with the binder for a smooth, consistent ink. High shear mixers and dispersants are used to get uniform color and prevent settling. Filtration. Inks, especially inkjet and fountain pen inks, are often filtered to remove any large particles or impurities that could clog nozzles. This can involve fine mesh filters or even ultrafiltration for very fine inks. Quality control. Manufacturers test viscosity, drying time, color strength, particle size distribution, and other parameters. They will tweak the formulation if, say, the viscosity is out of spec or the color is off. Color matching is done with spectrophotometers. For critical inks, like automobile paint or high-end publishing inks, batches must match standard color profiles. Scale and automation. Huge batches, hundreds or thousands of liters, can be made with computer-controlled dosing of chemicals. This not only improves consistency, but also safety, as many ink ingredients are flammable or need precise handling. Automation and enclosed processes also reduce workers' exposure to solvents and pigments, some of which can be hazardous. Environmental controls. Modern processes aim to minimize VOC emissions and waste. Solvent inks are made in closed systems with solvent recovery. Water-based inks avoid harmful emissions but require biocide management to prevent microbial growth and storage. Packaging and shelf life. Inks are formulated now to remain stable on the shelf for long periods. Anti-settling agents keep pigments from sinking in the can. pH buffers keep aqueous inks in the right range to avoid dye precipitation. Cartridges and bottles are filled in clean conditions to avoid contamination. For example, the manufacture of newspaper ink in the late 20th century might involve pumping soybean oil into a large heated kettle, mixing in a rosin resin to make a viscous varnish, then slowly adding carbon black pigment while a giant mixer agitates the blend. After hours of mixing and milling, the finished black ink is tested and pumped into 55-gallon drums to ship to printing presses. Contrast that with an 1800s printer, who might have mixed lampblack and linseed oil by hand with a palette knife on a marble slab. The modern process is faster, produces a more uniform product, and can meet high demand, e.g., supplying a city's worth of newspapers daily. In summary, historical ink making was a craft, small scale, manual, using natural ingredients with variability. Modern ink making is an industry, large scale, scientific, using refined chemicals and sophisticated equipment. The core idea of mixing colorant with vehicle remains, but today we can engineer inks for very specific purposes, e.g., an ink that prints at 1,000 pages per minute and dries instantly, or an ink that is biocompatible for printing organs, with reproducibility that old ink makers could only dream of. Learn more about art, history, and music at orensbooks.com. Please like and subscribe, and may the rest of your life be the best of your life. Oren Z. Belgrave.